Good afternoon, I am Mr. Ish. Thank you for joining me. Let's look here very quickly at this concept of power. It's a term which you see in physics. It's basically right here in a nutshell, the rate at which work is done. The rate at which work is done, you know the key word here being rate. What does rate imply? It implies the speed in a very layman sense, but it also talks about how slow or how fast something is being done. And what is that thing? We're talking about work. How slowly is the work being done and how fast is the work being done? Now, when we're talking about work, we're not really talking about cooking or studying, like that type of work or your job. We're talking about moving an object with a certain mass. That's what work entails. You're moving object over a distance and it has a certain mass. That's the key word or the key words. Look at these very important equations which build on each other. Force is equal to mass times acceleration. But look, mass times acceleration in a very different manner, very similar but in a different terminology, is also mass times gravity, which right here is your weight. If you're moving an object which is 100 kilograms, that entails the mass and the gravitational factor, because now you're looking at something with a weight. Keep that in mind. Here's equation, or let's just say these are our first two equations, but they're synonymous. The next equation, work is equal to force times distance. You can do this capital, you can do lowercase, I'll do capital. Well, anything which moves an object is force, but anything which moves an object over a certain distance is work, because work takes effort. That's your second equation. Newtons is your units here. Work can be represented in joules. That's a very good unit. Now, each of these, as I'm telling you, is building on the next. Power is your work done per unit time, or the rate at which work is done. Work divided by time. What's your units here? Watts. Excellent units to remember: newtons, joules, and watts. Force is anything which moves an object having a certain mass. Work is anything which moves an object over a distance. The effort needed to move an object over a distance. Power is the rate at which this work is done. When you keep that in mind properly, you will understand how the slowness or the swiftness of work being done makes sense with regards to the rate, and that is power. Power is not necessarily how strong something is. Power is how quickly something can be done. That perhaps is a source of confusion for some students. Imagine this example over here, and we can close this video with this example. You are standing here in a squatted position. You know what squatting is. A person squats a certain weight, they're going to lift it up. There's a certain weight a person is going to squat up. A leg exercise, of course, I'm not drawing it very well. Perhaps we should focus less on the drawing and a little bit more on everything else. I have a certain weight here, and the weight is 100 kilograms. What does this 100 kilogram entail? It entails mass and gravity. It's a weight. You're going to squat this up a distance of what, half a meter? That makes sense. We're going to move this up a half a meter, and we can just keep it in a fraction form, or you can do 0.5. How quickly will this person squat it up? That will be a power. A person A squats in a very slow manner, and he or she takes 3 seconds. They're probably doing a very slow movement to burn the muscle while they're doing it. And by burning, I mean like to get maximum calorie burn. Person B squats this weight, 100 kilogram, over a distance of half a meter in 1 second. Now, if I'm telling you, calculate me the power of person A, well, what is it? Power is going to be work over time. But what's work? It's going to be force times distance over time. But the force and the distance has a certain component, mass times gravity times distance over time. I know the mass and gravity, that's already 100. I know the distance, everything works right in. I have a mass and gravity, it's 100. You're going to keep everything in kilograms, and you're going to multiply by 0.5 meters is a good unit to keep it, and time 3 seconds. When I do that calculation, what am I going to get? I'll get 100 times 0.5 divided by 3. I'll get 16.66, or we can say 16.67 watts. This person has a movement over here, a work being done at a rate, and it's 16.67 watts. What about person B? What's the power of person B? Well, they're going to go through the same exact formula, mass times gravity times distance over time. And remember, the beauty of these formulas is if you know acceleration, mass times acceleration times distance over time, you can bring in velocity using this Vf is equal to Vo plus At. You can solve for this acceleration. You'll have Vf minus Vo over time, and now you can substitute this into your force right over here, and then this can go into your work, and then this can go into your power. All of that can happen. Anyhow, I don't want to digress too much. The weight is the same, 100. The distance is the same, 0.5 meters, but now the time is 1. What's this person's power? It's 50 watts. 100 times half, 50 watts. Now you should understand, power does not mean a person can lift more or less. Power means the rate at which they can do that lift, because that lift represents work, and that work represents a movement of an object of a certain mass over a certain distance. All of that has to be kept in mind. Power of person A's lift is 16.67 watts. Power of person B's lift is 50 watts. Now you can think about power lifters. You can have some pretty small sized individuals lift weights heavier than larger sized individuals because they're putting more power in their lift. They learn the technique and they can do their movement faster with good form. So keep in mind, rate at which work is done is your power. It does not necessarily have to mean someone is lifting a heavier object. It could very well mean they're lifting an object quicker or more swifter. All of that has to be factored in. Rate, work, your weight, the distance involved, all of these make sense. Lastly, when you look at this equation, power is equal to mass times gravity times distance over time. These three items are directly proportional to power. This is inversely proportional to power. And that's it for this video. Thank you for watching.